Good morning, everyone. So today what we're going to be doing is we're going to be starting our next unit, which will be on electricity and magnetism. And as you can see here, we're going to start off with Unit 5, Lesson 1, which is electricity. And so for the warm-up today, what I would like you all to do is to sort of think of why do light bulbs glow? And so that'll be what we're sort of doing today. And I'd suggest pause here if you want to answer that before I go into what we're actually going to be taught, like why they glow. So, as we learned previously with our light bulbs and sort of with electricity, we have sort of a flow of electricity and energy changes from one form to another. Now, when you have your electricity in a light bulb, you have your electricity going through the wires and through here and then there. And while it's in this, what is a tungsten filament, it doesn't really allow the electrons to move very easily. So what ends up happening is they end up having a lot of collisions and basically heating up the tungsten and causing it to glow and release a lot of that energy as light and as heat. Now, light bulbs themselves, they're filled with an inert gas to prevent a fire because normally these filaments are at about 2000 degrees Celsius, which means they end up getting really, really hot. And so they end up glowing because the filaments are filled with what are basically resistive and sort of have a resistance. And so what we're going to do is we're going to just do a little vocab here. So it resists the flow of electricity. And so basically, big note, resistance is basically reducing flow of electricity. And one of the big things here is there are three components to what is called a circuit and sort of how electricity moves throughout a system. We have uh, voltage, resistance, and current. And oh, well, that was not what I wanted it to do. So we have voltage, resistance, and current. And the best way I've always found to sort of explain what these three things are is when you think of, like, say, your kitchen sink. On your kitchen sink, you have yourself a little handle, a valve, or the faucet on the faucet, and your handle where you can sort of turn on the water to certain different amounts. That would be what would be equivalent to resistance. And basically, if you have the handle all the way on, or if you have the handle all the way off, it's basically interpreting as you have really high resistance when the handle is in the off position and really low resistance when it's on the on position off when it's on the on position. So basically, the resistance you have reduces as you turn your water on more and more. And one of the things that sort of ends up coming out, the flow of water, would be your current. Would be your flow. So how much water comes out would be like the current. So if you have a lot of water coming out, it would mean you have a high current. If you have very little water coming out or no water coming out, it means you have very little current or no current at all in your system. And similarly, we have our pipes, which basically the water pressure would be our voltage. So our voltage is sort of how much work can we actually do. And so if we have a lot of water pressure, we can end up having a really great flow coming out of our faucet. If we only have a little bit of water pressure, then it's just going to be a little dribble, similar to if, like, say, in your house and you happen to have, like, say, the sink's running, and if you have, like, a washing machine in your house, you have that going, and you hop into a shower, and you try to take a shower, and then there's just, like, a dinky little stream coming out of the shower head. That would be sort of an example of, like, everything else is also using the water pressure in the system or the voltage in the system, and it's really reducing how much you can do. So with this is just to sort of give us an idea. And what you will need to do today is actually use the book. So if you want to go onto the online textbook, hmhco.com/1, you'll end up with a screen like I have up here. And what you'll do is, once you get there, it'll tell you you'll have to choose your district. So we are in a district, state is California, and then down here you'll scroll down to Alameda Unified School District. Click Next. You'll log in with your email address and password, so it would be like first name dot last name at alamedaclc.org. And then you put in your password, which should be something like ACLC, and then a two-digit number. So after you log in, you should end up with a page like this. The current chapter we're going to be on is Unit 5. And so within this, we have you click on that, you can go to Student eBook, which will take a moment to load. Which will take a longer moment to load. Apparently it doesn't want to load. Alright, we'll try this, and let me fix the technical difficulty. Alright, so now I got it working. So after you end up logging in, you sort of go back to the let's just see. Boop. Oh, crap. Alright, so you click on Unit 5, and then what we're going to be doing is Lesson 1. So you can click on that, or you can just click Student eBook, and it'll load up the ebook for the unit, and then under Contents, we can skip over to Lesson 1, which is Electricity, even though it's really cool to sort of see the Tesla coil going. And what we're going to be doing today is we're going to be working on Explore Explain 1 and Explore Explain 2, and this will be sort of what I'll have you do for this week. So in Explore Explain 1, we're just sort of looking at the idea of how these charges move. So it's a little bit of like the example I gave you of of your sink, and sort of the faucet running, whether you turn on the handle, you have the pipes, and just sort of looking at it in terms of a light, or various light sources. And electrical energy is something we've talked about, and we're going to be just going into a little bit more depth of what electrical energy is, and sort of the idea of this electric current or the flow of electricity. Now, a big thing to sort of understand is in a circuit, our electrons move in the opposite direction that we consider the current to move, which is a little bit counterintuitive, but I do want to sort of bring that up. And then after we sort of talk about those moving charges and how it creates, or after you investigate or read about how those moving charges create electricity and current and sort of how resistance plays a role in it, You're gonna go on to Explore Explain 2, which will be sort of talking about how do you limit current. So how do you make light bulbs less bright, more bright, or anything like that. Um, and so in this case, you have an example where you have
Current through a copper cylinder.
cylinder and you have current through a nichrome cylinder. And as you can see, there's a difference in the amount of current that's going through. And that has a bit to do with both the properties of both copper and nichrome, as well as and sort of the size of those samples. So if you have there's a few things that sort of can go into how much resistance an object provides. And to sort of go with that, what we'll do is we'll look at these two ideas. I have two little simulations where you can sort of play around with these various things like voltage, current, and resistance. And over here we have an example of a wire. And so if we want to increase the resistivity of our wire, there's a couple things we can do. One of the things we can do is we just increase the resistivity of the material itself. So this would be like swapping out our copper for our nichrome. Additionally, we can do things like adjust the length and see how that affects our resistance. Or finally, you can see how big or narrow you make it to sort of adjust that resistance. And you can go ahead and play around with it and sort of see how those relationships interact. And then from there, you can go with this one, which is basically you have some voltage, you have some resistance, and then you're measuring the current. And so you can do similar things. You can increase your voltage, decrease it, increase or decrease your resistance, and sort of see how that affects the current. And then back to what you're going to be doing. So you'll read through that, answer the questions on the pages. This is under assignments on the ebook. Make sure to message me if you haven't gotten your password reset. And then, so read through these things. We're not going to be doing this lab, but we will be doing a version of one of the labs in here, building simple circuits, which we'll utilize another simulation for, and I'll talk about that later. And then what I would like you all to do is, after you answer those two, later next week, one of the things it's going to be due is this lesson self-check, which will be, you'll do the checkpoints, which are all these questions, just to sort of double check to see if you understand, or to like verify for yourself that you know what's going on, and it'll sort of, when you check, it'll sort of respond to you whether or not you get it wrong, so you'll instantly know, oh, do you understand what's going on, or do you need some additional help? And so this is going to be all for right now, and what we'll do is I'll be putting up another video, trying to do this semi-frequently to talk about what we're going to be doing. But I hope this was helpful. Message me with any feedback you want to give me as we sort of go through this distance learning process together and try to make the best of a weird situation.